You throw a rock upward at 30 meters per second while standing on a bridge. It hits the water below in 7.2 seconds. How high is the bridge above the water? So our picture's drawn. Here you are. You're going to throw it upward with an initial speed of 30 meters per second, but it's going to get slower and slower and slower on its way up because acceleration, as always, is down negative 9.8 meters per second squared. We're trying to find out how high the bridge is above the water. So what we're really ultimately finding here is the displacement of the rock that you threw, because the displacement is going to be basically the distance covered from the bridge to the water below. Pulling the numbers out, I know the initial velocity is 30 meters per second. The d is what I'm trying to find. The acceleration is negative 9.8 meters per second squared, and the time was given in the problem as 7.2 seconds. I'm going to pick the equation without VF in it, which is the third equation. D equals V naught T plus 1/2 AT squared. We actually have no algebra to do because it's already set up for D. So that's kind of nice for us. So I can just plug in my numbers. D equals 30 meters per second times 7.2 seconds plus 1/2 times negative 9.8 meters per second squared times 7.2 seconds. And that number is going to get squared. If I plug all of that into my calculator correctly, I actually get a negative 38.02 meters. Remember, what we were solving for here is the displacement of the rock. The rock ended up 32 meters lower, so that's why it was a negative 32. If you put that answer on a quiz or a test, I would mark it correct. In reality, the question said, hey, how high is the bridge above the water? That's not really a vector, just a simple number would suffice. So if you just said 38 meters is how high the bridge is above the water, that would be correct as well.